Okay, so in this video we're going to go over trigonometric special angles. Okay, so we're just looking at angles that are going to help us to be able to find the values of some bigger angles without us using the calculators. Let's say you're given a 90 or any angle less than 90 or greater than 90. Okay, so we are going to focus our attention on three basic angles that are going to help us throughout. So we're going to look at 30 degrees. We have 45 degrees. We're also going to look at 60 degrees. So when you look at these angles, they're just found in, like, they are within the 90 degrees itself. Okay, so you find that sometimes maybe you're given the question is asking to find sine, maybe sine 90. You know, to say in this sine 90 there is a 45 and another 45, or we can say there is a 30 and a what, and a 60 to make that 90 degrees that we want. Okay, so let's get to look at how we come up with the values. Let's say we are given this right angled triangle. Okay, um, okay, not as perfect. So we have a sign there showing us to say that is 90. Let's say we have a 30 degrees here. So this basically means to say here it's more like you have an angle which is x. So you know, to say for you to find this angle that is here, you're just saying your 90 which is here minus the 30. So we know to say for sure there is what, there is a 60 degrees. There's a 60 degrees there. Okay, so now, so if you have a 60 degrees here, or maybe let's say we put the 60 degrees here. Okay, so that appears to be much bigger. Then we put the 30 degrees here. So let's say you have a unit of 2 here, and here you also have a what, you have a 1 here. So the question is that how do you come up with the value that's supposed to be here? So it's more like you have, this is your A, this is your B, and that's your what, your C. So you have your AB. Your AB, we say it's what, it's 2. Your AC is what, is 1. So we want to find what BC or CB is. Okay, I want to find what that angle is right there. So here we can use the Pythagoras theorem. So we know to say this is the hypotenuse, this is the opposite, and this is the what, this is the adjacent. We know to say for us to find the opposite or the adjacent, we just subtract any that we have. If you have the adjacent, then you want to find the opposite. Subtract the adjacent from the what, from the hypotenuse there. And if sometimes maybe you don't have the hypotenuse, what you can do here is that you can just add the you can just add the the adjacent and the opposite. So what we can do here, we can say according to the Pythagoras theorem, we can say um, the we can say opposite squared is equals to what, hypotenuse squared minus what, adjacent squared. Okay, so this is our opposite squared is equals to, what's our hypotenuse, we say this is 2 squared minus adjacent is what, is 1 squared. So this is opposite squared is equals to 4 minus what, minus 1. So opposite squared, we find what, we find 3. So meaning opposite is equals to what, root of 3. So that's what we have right here. Okay, so now from these same values that we have here, we have a 2 here. Okay, um, we have a 2 here, we have a 1 here, we have a root of 3 there. Want to try to see what we are going to get if we bring in SOHCAHTOA, the sine, the cos, and the tan. Okay, so you know to say here we have found what, root of 3. So it's very important that we know this, because it's going to be very easy as we get to approach many questions, because it's not always when you're going to use a calculator, and this method here is going to help you to be coming up with values as fast as possible without even you thinking of using the calculator, even when you can access the calculator. All right, so here what we are going to bring in the issue of SOHCAHTOA. Okay, okay, so So what we know here is that this is more like SOH. This is sine theta is equals to opposite over what? Over hypotenuse. Then this is for cos theta is equals to adjacent over hypotenuse. This is for tan is equals to opposite over adjacent. Okay, so what we have here is that want to find the values of all of this in respect to the 60 and the 30. So we can maybe we can begin with the 30 degrees. Okay, we can begin with the 30 degrees. Under 30 degrees, we want to find out what the sine is. We want to find out what the cos is and what the tan theta is. Okay, so when we are looking at the 30, what you should basically do is that see it more like it depends on, say it more like it's like this. It's more like I'm going to ignore everything that everything that I have here apart from the 30 that I'm focusing my attention on. So here I have my 30 degrees here. Okay, so here you can see to say what we have here is what is a root of 3, and what we have here is what is a 2, and what we have here is a what is a 1. It's more like I've just flipped it the other way around. Okay, so I'm trying to ignore the 60 so that at least I don't have much to look on, may end up confusing me there. Okay, so here what I can do here is that I'm talking about, we know to say this is our adjacent here. Okay, that's our adjacent, and this is our opposite, and that becomes our what? Sorry, this is the hypotenuse. This is our opposite, and that becomes what? Our adjacent. Okay, the root of 3 is the adjacent, 2 is the hypotenuse, 1 is the what? Opposite. So we know to say for sine theta, here we know to say the theta is already what? Is already the 30. So you can say sine 30 is equals to, we know that from the formula, sine is equals to what? The opposite over what? Hypotenuse. What is our opposite right here? The opposite that we have is what? Is 1. And what's our hypotenuse? Is what? Is 2. Okay, so we can easily tell to say now the value that we have for sine theta is equals to what? You can say sine theta is equals to 1 over 2, which is just half if you put it in decimal places. That means 0.5 you put it in decimal places. So that is the value for sine theta right there. Even when you're punching your calculator, you're going to find that there are times when you have an angle which is 30. So if you don't want to waste your time, instead of you saying going on your calculator to place sine 30, just say 0.5 multiplied by whatever value that you want to multiply to. Okay, so now let's bring in cos now. Remember to say we are still talking about sine right there. Okay, so we bring in the issue of what? The issue of cos. So for cos, we know to say cos here. We're going to say cos 30 is equals to what? The adjacent over the what? The hypotenuse. This is our adjacent, and that's our hypotenuse. So our adjacent is root of what? Root of 3 divided by what? Our hypotenuse, which is what? Which is 2, and that is our value right there. So of course maybe it might look a bit scary for you dealing with a root of 3. We want to say that is that this is an irrational number, but you're going to find that as you do the multiplication, maybe you're going to find that you're going to be multiplying with a value that has another root right there, and yeah, it's going to be much easier. Okay, so let's bring in tan. Okay, we bring in tan, so you can say tan 30 is equals to opposite over adjacent. The opposite that we have is what? Is 1. The adjacent that we have is what? Is root of 3, and that's our value right there. Okay, so now we have come to find out to say the sine 30 is half, cos 30 is root of 3 over 2, then tan theta, or tan 30 rather, is 1 over root of 3. So now let's get to find out 60. Okay, 60 in this case. So I want to find what sine 60 is. Okay, what sine 60 is, what cos 60 is. Okay, remember I have degrees there. Okay, we also want to find out what tan 60 degrees is. So here is just us knowing how to how SOHCAHTOA works. Otherwise, everything is simple. Okay, so I guess we'll have to get rid of this one. We no longer need it. Okay, so what we have here is that for this 60 degrees here, for the 60 degrees, the opposite is this one. Okay, the hypotenuse is this one, then the adjacent is this one right here. Okay, so now when we get to sine, we know to say sine of any angle, or we can say now in this case sine of 60 is the opposite, which is this one, divided by the hypotenuse. The opposite that we have is now what? Is now root of what? Root of 3 divided by what? Divide by 2. Okay, divide by 2. Right, then we get to go to cos. So cos is just the adjacent, which is the one here, divide by what? The hypotenuse. So you see 1 over what? 1 over 2. That's what our cos is. All right, then we get to the last one, which is the tan. Tan is just the opposite, which is root of 3 divided by the adjacent, which is 1. So you are saying root of 3 divided by what? Divided by 1. So we can see some of the values are similar here. For example, we can see to say sine 60 is equals to what? Is equals to cos 30. Cos 30 there. And what else do we have? We can also to say sine 30 is also equals to what? Cos 60. Because we have a 1 over 2 here, we have a 1 over 2 here, we have a root of 3 over 2, and we also have the same right there. Okay, so those are the values that that we have there. Maybe we can try to put them aside. We have found out to say we have said sine 30 degrees is equals to 1 over 2. We say cos 30 degrees is equals to root of 3 divided by 2. Then tan 30 degrees, we have found that is 1 over root of 3. Then we have found out to say sine 60 degrees is equals to root of 3 divided by 2. Then what else do we have? We have cos 60 degrees. We have found that is equals to 1 over what? Okay, 1 over 2. 1 over 2 here. Okay, then tan 60 degrees, we have found what? We have found root of 3 divided by 1, which is just root of 3 itself. Okay, right, then we can erase this so that we bring in another angle. Remember to say I spoke about 3 angles, which is a 60, a 30, and a 45. And in this case, I want to try to find out what 45 has for us. Okay, so let's say let's give ourselves another right angle triangle here. Okay, something like that. So now we know to say here we have a 40, we have a 90 degrees there, then say we have a 45 here and a 45 here. Okay, I have a 45 there. So we know to say this is our opposite here, and this is our hypotenuse, and this is our what? Our adjacent. That is for this angle here. Okay, that is for that angle there. Then when you're talking about I mean, that is for this one here. When you're talking about this one becomes the opposite, this one becomes the adjacent, but that one still remains to be what? The it still remains to be the hypotenuse. Okay, so now let's look at the values that we are going to have. Let's look at the values that we are going to have. So let's say we have a 1 here and we have a 1 here. Okay, so we can also use Pythagoras theorem now for us to find what the hypotenuse is. We have the opposite, we have the adjacent. So we can say the hypotenuse is equals to what? Hypotenuse squared is equals to opposite squared plus what? Adjacent squared. So hypotenuse squared is equals to the opposite squared is what? It's just 1. Say 1 squared is still 1, even here 1. So meaning you have your h squared to be what? To be 2. So hypotenuse is what? Root of 2. So that's what we have here. Okay, so now I want to find out what sine 45 is. Okay, sine 45. So sine 45, we need to say sine is equals to opposite over what? Let's focus our attention on this 45 here. Let's say sine 45 is equals to the opposite, this opposite here divided by what? That one there, the adjacent. So it's 1 over what? Root of 2. Okay, so now what about cos? Cos is the adjacent. Okay, cos is the adjacent, which is this one here, the 1 divided by what? Divide by that one there. Okay, cos is 1 over root of 2 as well. Okay, so what about tan? Tan 45 degrees. Okay, tan 45 degrees is equals to what? The tan is now the opposite, the opposite divided by the adjacent, which is just 1 divided by 1, which is just what? A 1 right there. So we're able to say even sine 45 is equals to cos 45 as well. And we can also try to compare it with you can also try to compare it with the other angles that we had found earlier. We can see to say we can try to check what we have to try to make comparison. If there are some that are similar, then it even makes it much easier for us to be finding the values that we are looking for. Okay, so now let's get to practice a question in respect to what we were doing here. Okay, so we are given to say below is the diagram showing let me just try to make a correction question right there, showing okay all right, showing a parallelogram. Okay, so now here what it says, given that point B, this point here, okay, point B is the midpoint of AC, find FG. Okay, so what we're able to tell here is that it's more like the statement has told us to say AB is equals to what? BC. So whatever BC is, that is our what? That is our AB. And our AB is the same as what? We can also say our AB is also equals to what? ED. So now from the ED, we're supposed to find FD. So meaning we also have to have the angle, the value of what? The value of FE. Okay, so here for us to know what is here, we must first know what is where, what is here. Okay, so now what is our BC? So we know to say here what we have here is more like we have another 45 degrees angle here. Here it's more like we have a what? We have a 30 degrees here. Okay, so now want to find what is here. Remember to say for this 45, we can focus our attention on this 45 here. This is our what? Our adjacent. This is our what? Our opposite, and this is our what? Our hypotenuse. Okay, that is our hypotenuse right there. So now want to find what our A is here, our adjacent is. So we know to say we can bring in the issue of we can bring in the special angles that we earlier used. Okay, that we earlier used. So we know to say here what we have in terms of the 45 here, the adjacent here we have a what? We have a 1, and here we have also have a what? We have a 1 here. Okay, we have a 1 here and we have a 1 here. Here we have a what? A root of 2. Okay, so now us finding these values is so about us having the angles that we are using in mind earlier. Remember to say when you're using 45, the opposite and the adjacent is the same. If we go back to this work, we have the 1 here and we have what? We have a 1 there. So all the same, we have what? A 1 here. So meaning even here we have what? We have a 1. Okay. So now, what could be this one? This also basically means this is a what? This is a 1 here as well. Okay, so this is just for practice purposes. Of course, there are questions that are a bit detailed, but this is just to give us a picture of how these angles are able to help us in conjunction to any addition material that is given. Okay, then say what could be our FE? So we know to say when you're talking about 60 degrees, remember to say the values of the 30 degrees and the 60 degrees are a bit different in some ways. So when you go back to the previous work that we did, we know to say our 60 degrees has the hypotenuse 2 and has the what? Has the opposite root of 3 and the adjacent 1. Okay, so it's more like here we have a what? We have a 1. We have a what? We have a root of what? Root of 3 here, if I'm not mistaken. Right, yeah, that's how it is. We have a 2 there. Okay, so it basically means we have all the values of the sides. We have a 2 here, we have a 1, we have a 1 here, we have a 1, we have a 1, we have a root of 2 here. So now the question is asking us to find FD. So FD is just what? This FE, so we can say our FD, okay, we can say our FD is equals to what? Our FE plus what? Plus ED. So we know to say our FE is 1, our ED is also 1, then we get what? 2. We can say 2 units because maybe a question has not told us whether it's centimeters, meters, or something. We can just put 2 units, or maybe since I think let's just leave it like that without us using units because let's just leave it as just a value. Okay, then question B, I believe, is where we are going to need to, okay, this was A, then this is B, is where we are going to need to use the word unit. So what this basically means is that it's saying find the perimeter of the parallelogram. So what we have to do here is that we have to add all the values around this, and this, like that. So we can say we can start adding from FE. We can say FA plus AC plus CD plus DF. Okay, our FA is what? Is 2, plus our AC is what? Is also a 2, plus our CD is what? Is root of 2, plus what? Our DF is what? Is 2. So this is that's an irrational number there. We have a 2, we have a 2, we have a 2. They are giving us what? A 6. So it's a 6 plus what? Root of 2 units. That's the value of what? That's the value of the perimeter around that given parallelogram. And so that's how you deal with such a question. And just in conclusion, as we end, you're going to find that sometimes you are given, for example, let's say you have, let's say we use tan 30 degrees here. We know to say tan 30 is equals to 1 over what? 1 over root of 3. So now there are times when maybe you don't want to deal with a root on the denominator. You can find the conjugate of this. What do? You can multiply by the conjugate of this same denominator. What we mean by the conjugate is this. It's more like if you have A over B minus C. The conjugate of the denominator is just B plus C. Just change the sign of what? Of that one there. Okay, so it basically means if you were to multiply A over B minus C by the conjugate of the denominator, you're going to say you're multiplying everything here by the conjugate. That would be what? B plus C over what? B plus C. So just change the sign of this value here. So even here, what we have here is that we have this denominator, the conjugate of this denominator is negative root of 3. But there is no point of us putting negative, multiplying by negative root of 3, because they're going to, the sign is going to cancel. So it's more like you have negative 3 there, another negative 3 right there. That and that is going to go. So it's more like you're just going direct by you just saying 1 over root of 3 multiplied by root of 3 here divided by root of 3. When you multiply here, what you're going to have is root of 3 divided by, on the denominator that would be root of 3 squared. That root is going to go, the square is going to go, so meaning that would be what? 3 of root of 3 over what? Over 3. So this is another form that you can write this one right here, in case you don't want to add or multiply depending on the nature of the question, using 1 over root of 3. Yeah, so that's all from this video. Thanks for watching.